Good afternoon, everyone. The exams are all graded, and you should have comments in your grades. And you should actually see your grade in two locations, one under midterm one mom and the other one under midterm one upload. The comments and feedback will be in midterm one upload, and those two numbers should match. Now, if you feel that I've missed something or miscalculated, just shoot me an email and I'll look into it and get back to you. I think I have to mention a little bit of, about partial credit. Okay, so I basically look at it as if you were on a job, if you were on a job interview, right? And whether you get it right or you get it wrong, right? And either you're going to get the job or you're not going to get the job. All right. So one of the worst things I can do is say that somebody knows something when in fact that they don't. All right. This is engineering truthfully is more about performance than intentions or even effort. Okay. You've got to get it correctly done, and it's got to be all the way done. And I'm sure you know that. All right. But the professors that teach courses with 110 as a prereq are counting on me to uphold certain standards so that when they get to them, they don't have to re-review all of 110. Okay, of course, a little bit of review is good because even if a month or 2 or 3 months after leaving 110, information starts to fade. I just wanted to just remind you that in order to get the extra credit on the redo of the exam, right? All you have to do is redo the questions you didn't get correct, do them correctly, right? And then you can upload them into a spot in Canvas, which doesn't exist yet. All right. The other extra credit will be for you to either upload the study guide that you felt worked or upload a study guide that you wished you had now that you knew what the exam was. And again, I have to make that a spot for that in Canvas. But these extra credit assignments go into your homework, not into your exam grade. All right. And I feel that I do have to mention something, okay, in that the average homework grade, okay, was around 95%. The average midterm grade, was maybe 57, but that's actually 3 people they've dropped, but they something's going on. They're not really taking the course, but they're still enrolled. All right. So there's a big disconnect here. All right. And I'd like to know what's going on, right? So that I can do better, and you can just email me or come to office hours, right? But from some conversations I've had, people are just starting the homework really right before it's due. And this is, if I have number of questions and this is time, right? And this is the due date, and this is number of questions on the Discord server, right? We're getting that, which it's almost a step function, right? You've really got to work on the homework as you go along. You can't wait for it the last second. because it just won't have any time to settle in your head. And that could be one thing, right? You're doing it, it's just you're doing it too late. All right. I really don't like to use this time to preach, but you know, I'll do what I can to help you learn the material, right? But you kind of have to do your work, and homework, in fact, is just the minimum. All right. For success tips and things like that, you can come to me to office hours, right? Because I don't want to take up this time talking about that. Yeah. Um, Now the thing is sometimes what happens is you were doing the homework, you're doing everything right, and you still didn't do well on the exam, right? And what sometimes you just were having a bad day, or you just need to tweak things. All right. Um, and the thing is, I can't tell from your grades what's going on. I'm just throwing something out there, right? Um, but it's not just getting it on time, it's making sure that the week doesn't go by and you don't understand everything that I've gone over. Okay. But again, this was such a large discrepancy, I felt I should mention it. But every case is unique. And I know there's a lot going on in people's lives, right? But regardless of that, I have to verify whether you've learned it or not. Okay. And it's better to me than to tell you than an employer. Okay. Um, any administrative questions like that before we get going in today's topic?
Professor David,
Yes.
I was looking to schedule, this is about office hour question. I was looking to schedule office hour with you, and
Yeah.
we'll need the calendar to and time to schedule it with you. I'm wondering if we just click and save. Is that how you schedule? Because
Can you send me an email and I can maybe do a quick video? Because I don't know off the top of my head, because I don't make office hours with myself. That's a good question.
yeah, I have a
But you know what? Maybe somebody in the chat can answer it, because people do come. All right. But then, I just don't know right off the top of my head. Oh, here comes a chat, hopefully. Oh, many chats. Yeah. Hit save, hit save. And then eventually you should get an email that it's there. In fact, I get an email when you make one. Okay.
okay. Thank you.
All right. All right. Thank you, everybody. Anything else?
Professor,
Yes.
yeah, in the midterm, I don't see any comments, so I don't know which one I'm wrong or correct.
Okay. Shoot me an email and I'll look into that. Maybe I didn't click submit, but I don't want to do it now because everybody will see your stuff. Okay. Sorry about that.
Thank you.
Okay. Yeah. Sometimes I don't submit accidentally when writing the comments. And another thing is you got to be on a computer. You might not see the comments if you're using your phone.
Professor had a question about the midterm as well.
Yep. Just hold on one second. Yes, today's module 13. We're starting on system synthesis. All right. Now, yeah, please ask your question.
So for the comments that we got for each question, you put the number of the question, then the number right after is the score we got on the question, correct?
Yeah.
Okay.
Now, sometimes I'm in a rush, and when everything is correct, sometimes like it'll just be number 5 - 5 for some reason, right?
Okay, because I think
So-
well, I'll email you later, but I think in my, so, because you put it, the number of the question and then a number next to it, and then what we got wrong, right? So the
Yeah.
number next to it is the number we got on the question, right? That's what we got on it.
Right.
Okay, so then, yeah,
Again,
I
I
think,
could have made a typo or something like that. Just shoot me an email. I got no problem. Okay.
sounds good.
But guys, let me tell you, if you start hounding me about partial credit, right, that conversation is going to go nowhere really quickly. Okay. You might think it doesn't hurt to ask a question about, and when I say partial credit, like, can I just have partial credit for effectively no reason, right? I didn't make a mistake. There's absolutely no reason for it, right? Please don't do that. It does harm your reputation with me. All right. Not that it can't be repaired. Not that I'm going to remember it for very long, but please. Okay. Anything else? Okay. So I didn't have time to do one of those modules. And if you look at the Canvas shell, it kind of looks like we're going over advanced adders twice. But what happened is I was able to get to it last time because we had some time, right? And now we can start on system synthesis. And yeah, at the end, if we still have questions about advanced adders, I can do a few more examples. All right. Actually, I'm kind of remembering Monday, and it seems to be a bit of a blur. All right. So I think a few examples will be in order. So let's just, I'll just make up something. So, yeah, ultimately you will submit it online in Canvas. I don't think I'll be able to see everybody in office hours in time, right? But so what I suggest is if you are really stuck on something, make an office hour appointment so I can get you unstuck. But no, you just turn it in and I'll grade it. And if I have a question, I'll just let you know. But I said something that ultimately there's no way I can do. Sorry about that. So
Is this the advanced sumner or?
yeah, we're doing advanced summer right now. I think I went a little bit too quickly. Okay. All right. So we have 1, 2, 3, 4, 5 inputs, right? And we want the gains to sum to 0 to set up the dummy resistor. And so the gain of the dummy plus the sum of the gain whatever gains there are, right, needs to equal 0. This is what makes it work. Otherwise, you will get kind of a mess. So we have GD All right, and now let's just sum it. -1, -2, -3, +5, +5. All right, so this is -6, +5 is -1, +5 is 4, right? So GD +4 equals 0, thus GD equals -4, which means add dummy on negative side. Okay. So now I'm just going to draw the structure. And the first thing I'm going to do is get my negative feedback. And I'm going to assume 100 kiloohms right off the bat. I might be wrong here, right? And then I have 3 inputs on the inverting side. And I'm just going to label this, input 1, 2, 3, 4, 5. And yeah, that's R4, R5, R1, R2, R3. And I try to keep things organized like that because when I get tired or confused or whatever, I tend to make mistakes. But if I'm kind of doing things in an organized fashion, it'll be less of an issue. All right. So this would be unbalanced. Now I need to add my dummy, and all we have to do is tie it to ground, right? So we're adding a signal of 0, and this will balance it. All right. So this is the structure. Now we need to come up with the values, right? So R1 will equal RF, which is the 100K. And it's just easier to use the absolute value here. Gain 1. So 100K, gain 1 was 1. My absolute value is 1. So it's 100K. R2, absolute value of G2 is 100 divided by 250, and R3 equals 33.3 kiloohms. Now, a word, right? Resistors have tolerance, and we might not be able to find exactly 33.3 repeating, right? And so sometimes you can find a common denominator and work it out so that everything's even. But really, even if you were able to buy the exact value, the tolerance would vary it a little bit. Okay. So when you go to measure it, you don't get exactly what you measured, designed. All right. So R4, same thing. RF, and I believe that was 5. And R5 had the same gain, equal 20. All right. So I might have a little hard time drawing it in here. 20 kiloohms, 20K, 33 50K, 100K, and then I'll just do it over here. RD equals RF. I believe it was 4. $25K. Now, so that's pretty much it. We decided where the dummy would go. We calculated what it should be. We calculated what everything should be. And the inverting ones are on the inverting side. The non-inverting ones are on the non-inverting side. Right? And these two resistors are the same, and we've labeled out. Okay. I'm glad you think it's fun. It is relaxing, this particular type of thing. So let's just do one more. Okay, so Jeffrey, that's a great question. Why is the gain just a ratio for the non-inverting when before it was all 1 plus RF divided by whatever resistor you had? Well, I'll tell you. Is that when you put this resistor here and make it the same and balance the gains, it reduces to this. You can almost think that that +1 drops out. Now, now there's notes to this in the module from last time. And of course, I can't seem to find it right this second. If you go to the end, all of this is the proof that that works, okay? Which I'm not going to do in class, okay? But still, it's a great question. Yeah, Sahil, that's a great question too. What happens if the gain for the dummy equals 0? Oh, you just don't add it. Yeah, man, do it because I told you to. You know, you could do well in life if you do what I tell you to do, right? And I'm just laughing because we don't call him sensei, but at our studio, they call them quadranims, right? He said effectively the same thing. Just do what I tell you to do, right? And you'll do it right. And this kind of, anyway, it was funny that you said that. But if you look through the notes, I got this structure, right, an equation out of a op amp applications book, which I do mention in the Canvas shell. And what I suspect is somebody noticed something and then figure, hey, this works, right? Rather than just sitting down, because this is a bear to solve. Okay. But actually, I'm going to answer the second one first. So if I had V out equaled minus V1 minus 2 V2 plus V3 plus 2 V4, right? I can just see right here. Oh, I got minus 3, and here I have plus 3, right? So the gains cancel. There's none required, right? Right, and I can almost do now by inspection 100K, 50K, 100K, 50K, 100, 100, and make sure to label your out. That'll become really important later. You guys are really funny today. Okay, so that was the question. What if you don't need one? Yeah, that'd be great. Okay. So here, right, just to do it out more formally. So GD equal -1, -2, -4, +4. GD, well, those two cancel. So GD -3 equals 0. So GD equals 3 goes on the positive side, right? And so sometimes it's helpful to have so we had R1 here. I'm just going to draw it. Okay. So I have one, give myself a little more space. Right, I have 3 inputs here. 1, 2, 3. Right, I have a gain of -1. That becomes 100K, a gain of -2, 54, 25. I have 4, so that's 25 as well. And that's our D3, so that's 33.3K. All right. So, so the thing is, right, because the other way to do it would be to have an op amp here with 1, 2, 3 op amps, right? And then this one, I'd have to have an inverting stage. So that would be 1, 2, 3, 4. And actually, sometimes you need to do that. But in general, that's 2 op amps. That takes up board space. It's one more thing that can go wrong, break, die, right? You want to get as many mathematical operations out of an op amp as you can. All right. And so, and we're going to use this in what I would call a fancy filter architecture later. All right, any questions on that? Okay. That's a good question, folks. Why 100K? And the reason is, I tried a lot of other things that didn't work, right? Because even though we have this equation, right, there's really only one equation, but 2 unknowns, right? The 2 unknowns are RF and whatever these are, right? And so sometimes you have to try something and see if it works. Okay. So it would be, it's easy to show you. If what the problem is when it's too small. All right. So what if I had this circuit 100? Every gain is the same. So the negatives match the positives. So it's already balanced. Great. So basically, R1 equals 10K divided by 100, right? So that takes us to 1K and then 100. Okay. Now, op amps, they can usually only push out 100 or sink 40 milliamps. And actually, this is kind of a load, 10K. But, that's actually fine. It can actually, that voltage drop plus the parallel combination of these 200 ohm resistors will not, even if I'm at the rail, isn't going to cause a problem. All right. Okay. Now, what if I had an op amp driving this? Well, the load, let's do a superposition on the load, right? So this goes to 0, right? So I have 100 in series with 100 in parallel with 10K, which is effectively 100. So the load is around 200 ohms, which is too small for it to drive, and it won't work. Okay. Now, what if I were driving this with an op amp buffer? Well, if I were to do superposition, right, all of these would be tied to ground. This would be tied to ground. This is what's called a virtual ground. And so all that current is going to go through here, and you just get a 100 ohm load, and it just can't keep up. Okay. Then why not 1 meg? You can certainly buy 1 mega ohm resistors, right? This is a little more subtle, that if this is 100 mega ohms, there's a parasitic capacitor, an inductor, and sometimes it can act like an antenna to noise. I mean, everything creates noise, right? Resistors are a noise source when current goes through them. But it's really quite small. It's kind of hard to measure, right? But if something's acting like an antenna to radio waves, right? So you tend to stay away from 1 meg or even 10 meg. I'm not saying you can't do it, but it's a good idea to stay away from it for your first pass design. All right. And so what I've found is that if I chose 50, sometimes the problems don't work out. And the other thing is 100 ohms kind of limits the current, but it's not acting like an antenna. But you could probably go up to 500 ohms if you had to. All right. So that's really the practicalities of it. And you can think of something practical as like a boundary condition when you're doing a math problem, right? But it's just, here are some conditions that will help you to make decisions. But really, right, if you use 100K, 200K, or anything in your kit, and then calculated everything else properly, well, it would work, right? If I were creating an online exam and I didn't want everybody to use the same answer, I could randomly choose RF for you, and then choose a random equation with a random RF, right? And then everybody would have a random answer, hopefully correct. Okay, that was a bit deep, but that's the only way to answer that one. Okay, did that answer your question? Okay, yeah. Now, what I just said, though, is in those notes. So if you don't want to go through the whole video again, it's there. Okay. Okay. I haven't lost my mind. Okay. There's something that I had wanted to mention, and there's this great podcast, and it's about scarcity and why we keep I mean, it's a great title. Why do we keep digging when we're stuck in a hole? Now, yeah, I really want to help everybody do well on the exam. And then I notice certain behaviors, and professors can be like, why do students do this thing? Don't they realize X, Y, Z? And it's like, well, because they're having a, they're really under the gun, right? But the thing is sometimes one can start to do things that don't make sense when there's something scarce. Okay. And what I can imagine is that you're all scarce for time. Okay. Um, some of you want to graduate at a certain time, but you have to work to help take care of the family. It's even worse now because many people are on reduced or 0 hours due to the pandemic, right? And so all of a sudden you find yourself strapped for time. It becomes scarce, but then sometimes you do things that might not make sense. And so for one, you might say, well, I'm going to be deadline driven, and so I'll study for the exam the night before. I'm not accusing anybody of this, but I think I've done it too. Okay. So I can just be talking about me. All right. So, or let's just say you have a big push the night before the exam and you stay up late, you stay up till 3, 4 studying, and you're working hard. Then you come in, take the exam, and you're so dazed and confused, you don't even know what's question you're answering. And sometimes I can tell that you haven't gotten any sleep based on the answer you put down. So in reality, you should just go to bed on time and get a good night's rest. Cramming the night before will probably just make you tired and your grades will go down, right? Getting a good night's rest, something that we've all been told and we don't all necessarily listen to, especially when time is scarce. You think, well, I can make up that sleep later, right? So that podcast, Scarcity, it doesn't have anything to do with school in specific, but if you have a bit of time, which I know maybe you don't, you can give it a quick read while you're in the car or jogging or anything like that. I'm laughing at a comment from Manuel. Yeah, those energy drinks, of course. All right, well, anyway, you're making a joke, so. But yeah, I mean, in the Army, yeah, if like you had this mission critical thing and you had to stay up for 24 hours because, when I was in, it was the Soviets coming over the hill. Yeah, you would do what you needed to do. But trying to take an exam without proper sleep, right? It's pretty tough. And imagine if somebody was preventing you from sleeping or preventing you from breathing, right? That's the next thing I want to mention. Well, preventing somebody from breathing properly and preventing them from sleep, the other terms for that is enhanced interrogation techniques. And depending, on who's talking about it, it's torture. So if you're not sleeping, you're effectively torturing yourself. Okay. And also, I just want to spend a little time about breathing. When you start to get panicked, you start going, and then you're choking yourself out. So if you want some more information about something called box breathing, just send me an email, or we can even breathe in office hours. Okay. Sorry, I got a bit preachy, but yeah, the scarcity trap. And so sometimes I just have to tell people, when you're in a hole, right? Stop digging. But it's really hard when you're in the hole to stop digging. Okay, it's easy to say, but can be hard to do. Okay. Yes, it's Boo Quadranim. I'm a 4th degree. And my nickname, believe it or not, is Professor. Anyway, if you have, and actually after class, if anybody wants to learn about breathing or anything like that, we can stay after. Okay, we don't have to make an office hour appointment. Okay, oops. So far, I've kind of given you a system, either an impulse response, or a transfer function, or a circuit, and then you've told me what that circuit will do in time or what it will look like in frequency. But now we are going to start to go the other way, right? So what if I gave you a Bodhi plot? Anyway, so based on this, what is it? Shout it out or put it in the chat. Low pass filter. Yeah, it goes down with frequency, so low pass filter. Right. Yeah, and now people are adding in more detail. It's got one pole. Why? One breakpoint, and the slope is -20. Also, the phase only drops by 90. I should put minus there. Okay. Now, this is like an abstract painting, right? That gives us like kind of the truth of the system. And now I'm going to quote, let's see if I don't screw it up, Pablo Picasso. And he says, all art, I might be slaughtering this, but all art is a lie. But it's a lie that you need to begin to understand the truth. And the way I interpret that is, if you're trying to represent life in a painting, well, of course it can't be. The only thing to 100% life would be a complete universe, maybe 1 second ahead or 1 second behind, right? So you have to reduce the level of detail. But what is the most important part about that Bodhi plot? Well, those are the asymptotes, all right? And a gain of 1. So I'm going to have a gain of 1, right? I have 1 breakpoint or a pole at -100, right? Since it's 0 dB at low frequencies, right, I have to put the 100 here. Okay. Hey, Fernando, can you email that to me? And Justin, I don't know what about, was that a game ref? I'm sorry, I don't get that that was a game. All right. But email me what you're talking about, because it sounds interesting. Okay. So here's what we want, right? Well, how now make a circuit that does that? Oh, all right. Well, here's the thing. There's going to be an op amp there somewhere, right? In general, there will always be an op amp somewhere, right? And if I have an op amp in a filter or a system, you know, this is a linear time invariant system, that means I'm going to need a feedback resistance here, all right? Op amps can be used as comparators or like a logic device, and they're not really linear, right? So this is kind of like the baseline, right? So, you know, what are the first order things I know? Well, I have this, and I have this, right? Well, you know, if you're ultimately you just have these things in your mind, or there's these data sheets that have every kind of filter known, you know, every known filter, and you just start choosing, right? But yeah, you know that that's a low pass, and you know that that's a high pass. You've already, guys have already identified that, right? So here, oops, here, there's our input, our C, and then, you know, is there going to be gain here or not? No. So I can set R equal to 0, which is what? It's just a buffer, right? And then that resistance goes to infinity, so it's not there. All right. But basically, you have this structure somewhere written down in your head, and you know that. And the reason why you have the op amp is that if I put a load here, right, the op amp isolates it. Because if I put a load here, now the time constant is different. Okay, so we don't do that. Now, we have 1 over RC equals omega naught equals 100, but I have two things, right? But I do have one boundary condition that we really want R's in general greater than 2 kilo ohms. All right. So that's just like a boundary condition. All right. So what we do is say the capacitance equals omega naught divided by R. Nope. I don't like that color. Sorry. R equals one divided by omega naught C. And what you end up doing is choosing capacitors, right? And then seeing if R is greater than 2K. All right. And the thing is capacitors, why choose the capacitor first? Is because there's less choice. Okay. So so there's a place Anchor Electronics. You can pick up kind of any part you want. They are open. You just have to wear a mask. And this is their parts list. And these are surface mount capacitors. All right. But you can see, and this is basically how big they are. 0 to 1 are just tiny, but you have 1 picofarad, 2.23, so on and so on, right? So see, there's not very many choices of capacitors, but with resistors at 1%, you have a lot more choice of resistor. Yeah. Actually, I should make extra credit. You go over there and take a picture in front of the anchor. So, and what I tend to do is I try to keep the same. I try to have it keep as few parts as so, you know, I can say C equals 1. Oh, and then another thing is, you know, R should be less than a mega ohm, right? So it's a range. So if capacitance is 1 microfarad, right? So R equals 100 times 1 times 10 to the minus 6. So what's that, 10K? I don't know why I doubt myself. Okay, 10K. Is it between these two values? Yes. All right. Now, here's the thing. So that let's just look at the Bode plot of the magnitude. Okay. So that should be 100, right? But that cutoff frequency will vary depending on the value of the resistor, right? And the smallest it can be, no, the biggest it'll be if the resistor and the capacitor both happen to be at the small range, right? You'll go out a little bit. And if they both happen to be at the big range, you'll come here. So based on the tolerance, the circuit could be working even if it's not exactly 100. Right. So what if I chose a picofarad, right? So R equals 10 squared times 1 times 10 to the minus 12, right? That's 1 over 10 to the minus 10. That resistor is going to be huge, right? So a picofarad would be too small, right? Now, if I chose, what did I choose? I choose 1 microfarad, right? Well, I could choose 100 nanofarads, right? And I'd get 100K and it'd be okay, right? But I guess it seems to me after doing these problems for a long time, choosing this first seems to work. But yeah, you might have to go down to 20 nanofarads, all right? And if I chose, what if I chose 100 microfarads, right? Well, then the resistor would be too small. Okay. So it can be a bit of a trial and error. And I guess is over time, that value works for me. Exactly. Folk. Choose the resistor in the list and make the filter. Exactly. I'm just making sure I answered everything in the chat. Okay. So that's, that's just a simple thing, right? But so here, right, I have a transfer function times a transfer function, right? And so I have a low pass, I have a high pass here and a low pass here. Well, and the gain is, oops, yeah, 1, so I don't need those resistors. All right, so that's with these op amps, right? You just scale them in and then you choose those values, right? And this would be a bandpass. You got it, bandpass. All right. So the thing is there's the series synth technique where you have everything's in terms of HS. Okay, you have H1, H2, H3, right? I have an input and then I have an output, right? And so what I can do, let's see if I can do this. Each one of these can be an op amp circuit, okay? That then I put in series, okay? So, and then there's so many configurations, right? Right, so if this is just 10, right? Oh, well, that's just a gain stage. Right? If this is 20 divided by S plus 20, right? Then that is my low pass. Oops, minus. Whoa. Right, and followed by whatever op amp circuit is over here. Okay, so you just multiply everything in series. So we've already kind of been doing that already, right? We just call it cascading stages. Tara, that is a good question. No. I mean, this is an inverting gain stage, right? This is actually an inverting low pass filter. Then I have to. I think that's inverting high pass. I'd have to do it out. Okay. But then you also have things like that. And you also have something called an integrator. Okay. And so if I wanted something S cubed, right? Well, then I would have one of these here, one of these here, one of these here. But in fact, then I'd get 1 over S cubed, but it would be inverted. And then I would have to add another stage to get it to be non-inverted. All right, so here's our inverting integrator, which we'll be using quite a bit, actually. We'll call that out. All right, so that's minus 1 over RC S. So if the target is 1 over S cubed. All right, well, how do I get that? I got to break it up into 3 integrators. So that means 3 R's, 3 capacitors, 3 op amps. And there are op amp circuits that you can get more than one integrator out per stage. And I'm going to keep all the R's and C's the same. Okay. So this would be minus 1 over RCS. Then this would be 1 over R squared, C squared, S squared. And then this would be minus R cubed, C cubed, S cubed, right? And I just, if R equals 100K and C equals 10U, right? I know that that's going to be 1. But now it's inverted. So now I have to add some inverting stage. And now I needed 4 op amps to do that. Now here's the thing. We're going to start doing a feedback network where sometimes you're going to want it to be positive and sometimes you're going to want to be negative, but we don't need this inverting stage here to make that happen, because with our advanced summer, right, we can bring it in on the negative side or the positive side, however we feel like it. Okay. But that'll be for kind of another day. Well, not to let you go early, 3 minutes early or anything. All right. But let me stop sharing for a second. I just want you all to know that I do care about you very much. I know there's 84 of you, and maybe you might not be getting my direct attention every day, but I really do care about your success, right? Everything I do is to try to get you to be the best that you can be, all right? And so just know that, okay? Anyway, that's it for today. I know if you want to stick around for breathing exercises, that's great too. But I'm going to stop recording.
Appreciate you, Professor.
No, appreciate you.